Okay, assalamu alaikum. Good afternoon, everyone. So now we are going to move to the oral presentations, and we have 6 of them, very interesting ones. And we will be introducing one by one, 8 minutes for each presentation. We'll allow 2 minutes only for maybe one question. So that will stick to time as much as possible. So we're going to start by Prof. Mirsadat. He's a consultant, a senior orthopedic surgeon, and also a teaching staff in the College of Medicine Institute, the Institute of Research and Medical Consultation in Imam Abdurrahman bin Faisal University and King Fahd Hospital University. And he's going to address a very interesting subject on genetic influence on osteoporosis and fracture risk outcome of the genome-wide association study. Prof. Sadat.
Assalamu alaikum. Good afternoon. It's an honor to be here, and I really congratulate the committee of accepting a new subject on the platform. We have been hearing about the BMD and osteoporosis, and now I want to put up a new subject on the platform. Let's see how we go forward. This is my disclosures, not many, and the disclaimers. Particularly, I need to highlight that the opinions which I am giving is my own and based on the literature. The plan of this, initially it was 10 minutes. Professor Mona reduced to 8 minutes. I'll go a little bit faster. The plan is, first I will want to address what is the Human Genome Project, basic of genetics, review of the genome-wide association studies, what it means, and then I'll come to the genetic influence of osteoporosis in Saudi population, which was published about 11 years ago. Now, Dr. Paul Berg, he got a Nobel Prize for isolating DNA long time back, and unfortunately he died this month as per the announcement of the Stanford University in California. He said that all human diseases are genetic in origin. And I really believe it. As we go forward, we will understand. Now, what is a genome? A genome is all the genetic material which the human body has. And the genome-wide association study is an approach of scanning all the genomes from the different population in the world and putting genetic markers together which will predict the disease. If a child has a GWAS, he will know at the end of the result that at the age of 25 years, he can have osteoarthritis of the knee, like at 40 years, he will have osteoporosis and so on. Now, Human Genome Project actually started in 1990 and ended in 2003, but the final report did not come up till 2004. And based on the final report, these were the aims of the study. What they did was they isolated 100,000 genes in the human DNA, which have got 3 billion bases where the allele markers were there. And then they stored the data to predict the disease when it will happen. Now, the basic of the genetics, this is the word which I'll be using in the presentation, is the genes and genome, what are the chromosomes, and what is the DNA, and what is the locus and allele, because locus is important exactly at what level of the chromosome and the DNA and the gene this allele is present, which will influence the disease. Now, the objective of the review was to find the genetic markers, are the genes, which will tell us what is the risk of osteoporosis, BMD, and fragility fractures. The study looked into all the databases available, including the human genome from the Europe, UK, and North America. And then what we found that there was 55 genome-wide association studies published during that period, which based on BMD, fractures, and osteoporosis. All this involves about more than 1 million patients. The database for osteoporosis alone is 1 million and the controls. They have found that 144 genes at 515 locuses influence the BMD and osteoporosis. But they went one step further and they found, after a study of over less than 200,000 patients with fractures and 377,000 patients who were controlled, that 15 more locuses are involved, a genetic marker present on the allele, which cause a fragility fracture. Now, unfortunately, all the Human Genome Project came from these different countries, except Saudi Arabia and the Middle East. Now, in that case, we have to control their genetic markers with our genetic marker. This is what we are doing for a long time, the BMD of the North American, BMD of the European, same we are comparing to our own projects. Now, in 2012, we published a study in Journal of Osteoporosis. Me and Professor Haifa from Al-Turki from the OB/GYN department. That what we did was we studied 200 patients with osteoporosis with and without fracture. And we looked for the ethnic population. That means at least the 3 generations have to be Saudis. That's what we studied. And then we looked only for the 3 genes, which is ALOX15, LRP5 gene, and tumor necrosis factor gene. These are specific on different chromosomes. Now, ALOX15, which is present on 17 chromosome, majority of our population, Saudi population, with the homozygous CC allele had about 70% of the population had this particular gene. BMD at this region was significantly lower, but they did not fracture. This is the difference we have to understand, that BMD is not alone a risk factor for fracture. Even though these population had a low BMD but did not fracture. LRP5 gene, chromosome 11, here our population had 96% of them belong to the CC and CT alleles. In this particular one, the BMD was higher and the risk of fracture was lower. Then, through tumor necrosis factor, this is where the crunch comes, which is the GG allele, which is very common in the Western population, even in the Human Genome Project. But the incidence of fractures in this particular gene is about 33% higher compared to the other group. In Saudi population, this allele was present only on 4%. That gives an indication why our fracture risk or average is 5 or 6 per thousand compared to the Europeans and the Scandinavian countries. Now, Richards again in 2008, chromosome 8, new tumor necrosis factor, they said the association of low BMD risk of fractures is present with A allele. Again, this locus is lower in Saudi population. Since we studied only 3 genes, so we concluded that there is a similarity between the genetic markers and the genes which influence osteoporosis, very similar but not completely to the Western population which has reported. Now, for 100% accuracy of prediction of a fracture, we have to build our own. Like last 20 years, we are trying to find out that we must have a standard of the BMD, epidemiological studies. We failed in that. We don't have our own database, what to use for BMD. Till that period, unfortunately, we have to compare the genetic markers of the Human Genome Project. Now, luckily, 2014, under the vision of 2030, Saudi Human Genome Project was announced. But to our surprise, they should have looked into the more common diseases. Instead of that, they are looking for the rare genetic diseases, which will be rare. And unfortunately, we are spending much more higher amount of money on more common diseases than the rare diseases. Now, 1 minute, okay. I believe that Saudi Osteoporosis Society should combine with the Saudi Genome Project to see if we can do at least 1,000 total population to have a genome and to see exactly which genes are much more reliable. Now, another last half minute, I'll talk about the whole genome scanning. This has become very important. Like a lot of women are undergoing the BRCA1 and BRCA2 genes, and then the RANK-L gene came up for the denosumab. The SOS gene came up for the drug of romosumab. All these have come out from the the Human Genome Project. Now, what I believe is that at present, individuals are going for the test which costs less than 4,000 riyals, for at least to know that what diseases they are at risk. Recently, this came in 2011, and very interesting to know that this child wants to know what is his future. Right now, the Human Genome Project predicts at least 25 diseases which are very common, and then 6 to 8 cancers. Recently on my Facebook, somebody posted this one. This is being done in Eastern Province, a clinic which is doing all these studies, and then I found the osteoporosis included in that. Thank you very much. This is my co-authors. I thank them from the different departments. I'll take the questions if they have any.